Okay, this is section 5, law of cosines. So rather than ask you to write out all these formulas yourself, I printed them for you because they are kind of long and complicated, and if we miss a negative or a minus or a times instead of a plus, it comes out incorrectly. So in order to find a side, we would use this formula, and in order to find an angle, we would use this formula. Now all three formulas in each column are the same formula. If we have an A in the front, we do the cosine of A, and then B and C, the other two letters are inside. So we're trying to find side B, we would use angle B. We're trying to find side C, we'd use angle C. Solving for the angles, notice that they're interchangeable. Again, the angle, we'll put the side first, the angle, we'll put that side first, that angle, we put that side first, and then the B and the C and the A and the C, B and C, A and C, those are the same. So, when we're doing law of cosines, that means you either have all three sides and no angles, or you have two adjacent sides and the angle in between them. Let's try using some of these formulas. They look confusing, but once you get the hang of them, they're pretty easy. Okay, so I'm going to start by trying to find this side right here. The formulas up above tells me that I need to do a squared, so here's side A, plus b squared, so here's side B, minus 2 times A times B times the cosine of C. So I will do 3 squared plus 2.5 squared minus 2 times A times B times the cosine of C. 3 squared plus 2.5 squared minus 2 times 3 times 2.5 times the cosine of 28 equals 2. Now this is not the answer to the length of this side. Up above, notice that the formula solves for C squared, not for C. So to get C, we have to do the square root. The square root of 2, which is 1.4. Now that we have side C, we can use one of the angle formulas to find the measure of angle A or angle B. I'm going to go with angle B. To find the measure of angle B, we would do the cosine inverse of B squared minus A squared minus C squared divided by negative 2 times A times C. Now notice I have a double parentheses in front and a double parentheses in the end because this is really a big fraction, and I want my numerator in a set of parentheses and I want my denominator in its own set of parentheses. So if I type this correctly, it should be the cosine inverse, an extra parentheses, 2.5 squared minus 3 squared minus 1.4 squared, close my numerator, divide, open my denominator, negative 2 times 3 times 1.4, and then close the parentheses, and that tells me that the measure of angle B is 55.9 degrees. I think some of these, that's a decimal and that's a times. So then to find the measure of angle A, I could do the formula all over again, or I could think back to geometry and remember that 3 angles of a triangle always add up to 180 degrees. So I already have 28 and 55.9. I need 96.1 degrees to finish off 180. Okay, this is the continuation of section 5, law of cosines. Two hot air balloons approach a landing field. One is 12 meters from the landing point and the other is 17 meters from the landing point. The angle between the balloons is 70 degrees. How far apart are the two balloons? So I'm going to say this balloon is 12 meters from the landing point. I'll say this balloon is 17 meters from the landing point. The angle between them is 70 degrees. How far apart are the balloons? So I can add letters to this triangle just to make it easier if I want to. I'll just call this angle A. I'll call this angle B, which makes this side B. I'll call this angle C, which makes this side C. So my X is really side A. My formula above to solve for side A is a squared equals b squared plus c squared minus 2 times A times B, B times C times the cosine of angle A. So A squared is 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 70. 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of 70 equals 293.5. Now remember, this is not 293 meters long. This solved for a squared, so to get A, we have to do the square root. The square root of 293.5 is 17.1 meters.